Welcome back. This is Alex, again going through the College Board question bank. We are working through linear equations in one variable, starting with question 46 in the document, ending code AE4. If you haven't watched any of the earlier videos, I encourage you to do so. We go over some critical definitions, some strategies for questions that we've encountered so far. And we will very likely see similar ones today. And as we go through these, I'm spending a little less time explaining the strategies and just applying them. Again, I encourage you to pause the video before I attempt each question and to try it on your own as we go along. I do make mistakes. I'm doing this live, not going back and monitoring myself. So if I do mess something up, feel free to leave a comment criticizing my techniques or my foolishness in the section below. But without much further ado, let's go ahead and finish this document up with question 8 ending AE4. And I am referring to the ending of the code at the top there when I say that. All right, we got 2n over 5 equals 10. I see we're not looking for x or n, we're looking for 2n minus 1. And you'll remember in the last video that I did indeed make a mistake on something similar to this. We want to know that, not n. So I'm going to learn from my own mistake. So let's go ahead and multiply 5 over, and we get 2n is 50. We could continue and solve for n here, but I see 2n in my expression up there. If 2n is 50, let's just plug 50 in right there. 50 minus 1 is 49, giving us the answer B. I don't know what n is. I don't care what n is. Neither should you. 47. If you want to do math and listen to some cool music as you go along, I'm currently listening to jazz, relaxing music, and cozy coffee shop ambience by Coffee Relaxing Jazz over on YouTube. If you want to listen to that as we go along as well, feel free to tune that in. It's actually kind of nice. All right, we got B3B. Is our ending code. 1/2 x minus 1/6 x equals 1. What is the value of x? Simply, all right, we could combine like terms if you're comfortable with fractions. Good for you. You could go ahead and just do that. I hate fractions personally, so I'm going to multiply each term here by 6. That gives us 3x minus 1x equals 6. Every term gets multiplied by 6 to get rid of the fraction. So we get 2x equals 6, and x, of course, then is 3. That is much easier to work with than keeping the fraction around. 95b. Give it a shot. If you were watching our last video, we have a trick here. We have a strategy to plus x equals 60. We've got 16 plus 8x is our thing that we're solving for. So the multiple here is 8 times 8 this time. 2 times 8 is 16. 8 times x is 8x. 60 times 8 is 480, I think. Moving right along. 49. Ending 122. We don't care about the context, so you can just kind of pull the numbers out of these. You just got to know how it fits into the linear expression. Is it a slope? Is it a y-intercept? What is it? Is it an xy coordinate point? What are they giving us? We get p dollars per hour for the first 8 hours. So p dollars per hour when let's say n hours when n is less than 8. Plus 1.5p, so 1.5p for each hour over 8 hours for n greater than 8. Not per n hours, but it's per each hour, so that should not be n in the bottom of there. It should just be hours times n hours. And the hours cancel out, and this would be times n as well, but it's when n is greater than 8, so that'll be n minus 8. Okay, Megan worked for 10 hours and her total earnings for that day were $137.50. So we get 137.5 is equal to P times 8, because she gets P for each hour up to 8, plus 1.5P times 2, because that's how many hours she worked past 8 at 10 minus is 2. Okay, we can combine like terms here. 1.5 times 2 is 3. 3 plus 8 is 11. 11P equals 137.50. I can't divide that off the top of my head, but I know it's bigger than 12. How much bigger than 12? I'm not sure. I don't know if it's C or D. So not trusting myself, I'll use a calculator. Divide, ooh, it is 12 and a half. So there we go. I should have known that. All right, 12.5 equals P. What is her hourly wage? Just double checking the question. That is going to be B. Always double check. We avoid mistakes like the one I made last time. We got question 50, ending 1A0. 3x plus 2 equals 8. 9x plus 6 equals what? We're seeing quite a few of these. This is times 3. 8 times 3 is 24. Sorry, didn't like the way that looked. There we go, 24. 51. We got 8e8. Okay, plus 12 is 336. Subtract the 12, of course, and we get 324. That's barely even a question. How many solutions does it have? Don't be fooled, there are 2. Question 52 is a classic SAT question. Is this also 88? Ah, that's funny. They have the same ending. Thought those would all be unique, but I guess given enough time, we're going to find 2. It's weird that they're right next to each other. All right, so I was saying this has 2 solutions. 66x equals 66x. How does it have 2 solutions, you might wonder? Well, x could be 1, or x could be 0. Oh, wait. No, it could be anything. It's infinitely many. This is kind of weird. This is particularly weird because the coefficient is the same. If those coefficients were different, let's say we had like 72x equals 5x. If those were different, then there would be one solution. It would be x equals 0. If they were opposites, if we had like 2x equals negative 2x, it would be two solutions. Is that true? No, because you'd try like x equals 0, x equals negative 1. Plug in the negative 1, you get negative 2 equals 2. Yeah, that's not true, so just 1 there. So if the coefficients are different, it's one solution. If the coefficients are the same, it's infinite. This gets funny when you square the x, or when you have like a square root of x. But if it's just x, the coefficients, just like parallel and perpendicular lines, if the slopes are the same, they're infinite. Slopes and y-intercepts are the same, it's infinitely many solutions, so it's got to be C here. Always be critically thinking, never trust your assumptions. It's life advice there. All right, we got 53, ending 01B. Okay, has no solution, parallel line, right? And if they're parallel, the slopes are the same, so A is 9, so number 1 is true. AB is 5, so A times B equals 5. And if A is 9, That's 9b is 5. B is therefore 5/9. So 2 is wrong, 3 is wrong. And that must be answer B. Just quick double check of myself here. Has no solutions. Oh, has no solutions. There we go. This is why you double check. If it was infinite solutions, then B would be 5/9. But if it has no solutions, that means that you have the same slope with different y-intercepts. No solutions, same slope, different y-intercepts. So if B in this scenario is 5/9, to make them equal, they're going to be true, blah, blah, blah. Yeah, B cannot be 5/9. So 3 is also true, so that's going to be D here. If you want a proof of that, plug it into Desmos, graph it, and you'll see that these things indeed would be the same line if B is 5/9. We can, I guess, algebraically prove it real quick. You got 9 out there, you got x plus b, then you got 9x plus b, or 9b. If b is 5/9, then you got 9x plus 9 times 5/9. These cancel and you get 9x plus 5 equals 9x plus 5. That would have infinite solutions. We don't want these to have infinite. We want them to have none. So B cannot be 5/9. Otherwise, they have infinite. B could be 5. It does not have to be 5. So 2 is not included in our answer. All right, what do we got here? That was 53. 54. A7F. Okay, I'm going to zoom out so you can read that. Okay, we've got a y-intercept, 467,000. 21 seconds. We have a xy coordinate point here, 21, 36.2. On average, how much did, so they're giving us 2 coordinate points. The y-intercept is 0, 467,000. And another coordinate point, 21, 362, 105. How much did it burn each second? So that's the slope, basically. Yeah, we don't need to set up an equation like y equals mx plus b or anything like that. Just use the definition slope, change in y divided by change in x. We're going to get a negative number, but it doesn't matter. They want how much was burned each second. They don't want it like by how much it would. Yeah, the negative doesn't matter. So difference of that one, big number. So using a calculator, 467,000 minus 362, 105 gives us 104,895. 104,895 divided by 21, because that's the change in the x's, is 49.95. Sounds like the price of something you'd buy off an infomercial for $49.95. But anyway, 55. We got EF8. Okay, we have $60. That's a y-intercept. 3 movies at $7.50 each. Renting movies for $1.50. How many can he rent? So we start with 60. We have spent, what is that going to be? $22.50 or something like that. 3 times 7.5 is, yep, $22.50. So subtracting that, 60 minus 2250 is 37.50, and he's going to spend that on rentals at $1.50 a pop. So he's going to get 25 of those bad boys because we just divide that over. Because it's $150 each rental, and that equals our remaining cash. So we just divide it over, and we get 25 of these guys. That's B. How are we doing on time? We got 15 minutes in. 56. F0. Width is W, so I will draw a picture for this one. Width is W. Floor is 6 feet longer than the width, so 6 plus W. What are the lines? Perimeter. So perimeter adds up all four sides. So we're going to get 4W plus 12. That's going to be B. We get 57. Ending 129. Okay. 43 books to distribute. Each child gets 2 books. They get 7 left over. So 43 minus 7. How many children are in the group? Divided by 2. Yeah, I think that's what I'm going to do. 43 minus 7 divided by 2. Where that comes from. So if I take the population of kids, divide it into groups of 2 and add 7 to it. Is that right? No. Divide by 7. Let's talk through the idea here. So if I want to have each kid to have 2 books, so the number of books is equal to 2 times the number of kids plus 7. And then we subtract the 7 and divide by 2. That's where this comes from. 43 minus 7 is what? 36? 36 divided by 2 is 18. That was 2 books for each kid and 7 left over. Study that for a moment if it doesn't make any sense for you. Kind of blasted through that one, I'm sorry. All right, 58. We got OB6. Got 6x plus k, 6x plus 5. Without reading the question, we can predict that this might be a like infinite solutions or no solutions question. Infinite solutions means k is 5. No solution means k is anything other than 5. There's infinite solutions, there we go. So k is 5. We've got number 59. We're getting close to the end here. And this code is 0A9. 5 stations for a science lab. Each station will have experiment A or B, but not both. A is 6 teaspoons of salt. B is 4 teaspoons of salt. X is the number of stations for A. And the remaining stations are B. Which of the following represents the number of teaspoons of salt required? Okie doke. There are 5 stations total. So the stations for A plus the stations for B equals 5. X is A. That means B is 5 minus X, of course. So the number of teaspoons of salt, that was 6 for A. So 6X plus however many we need for B. B, in terms of X, is 5 minus X. So 4 times 5 minus X. And that gives us our expression for the number of teaspoons of salt, because it was 6 for A and 4 for B. A is X, B is 5 minus X. We can distribute this through. 6X just stays 6X. 4 times 5 is 20 minus 4x. So we get 6x minus 4x is 2x plus 20. So we get C. Which is funny because if you have 0 experiments, you still need 20 tablespoons of salt. But that's just how it is. But anyway, I guess that would be x is 0, so there are no experiments for A if you just did B's. Which makes sense. Makes more sense. 6D, numbers B, B, D. Okay, what is x for a solution? So simple distribution. I hate fractions, so I'm actually going to multiply this whole thing by 12. So that would give us 3x plus 5 minus 4x plus 5 equals negative 7. So the repetition of x plus 5, you could try the trick where you replace it with a simpler term, but it doesn't really get us anywhere here because we do have to solve for x. So distributing this through, we're going to get 3x plus 15 minus 4x minus 20 equals negative 7. Combining like terms, we get negative x minus 5 equals negative 7. Add the 5 and flip the sign. We get negative x equals negative 2. X is 2. I messed something up. Oh, I didn't multiply this by 12. 7 times 12 is what? 70 plus 14. So 84 should be on this side. My bad. Negative 84. Add the 5 and you get your 79. And then flip the sign and we get 79 positive. So C. Got to multiply everything by that coefficient, not just the left-hand side. But catching yourself is key. Here we can use the trick. Notice that we've got x minus 5 is what we're solving for. So I can do 2a plus 3a equals 10. So that's 5a is 10, a is 2. Don't care what x is, just substitute it out. 62, a21. 2x plus 3 equals 7. 2x equals 4. X equals 2. Little algebra stuff. 63. AA4. 5x is 20. What is 15x? You could divide it over and get x is 4, then multiply by 15 to get your 60. Or you could just say, okay, 5x is a multiple of 3 away from 15, so just multiplying both sides by 3, you get 60. A couple strategies there. Time saving. They want x plus 6 here. X equals 40, so 40 plus 6 is 46. Don't overthink this. Why is this even a question? That was 3F1. And our last question, 062. 17 ounces of wax. When the candle is burning, the amount of wax decreases by 1 ounce every 4 hours. Okay, so y-intercept, and it's decreasing. 1 ounce every 4 hours, if x is the number of hours. 6 ounces of candle wax remain. How many hours has it been burning? So we say that's equal to 6. Add the 1/4, subtract the 6, we get 11 equals 1/4 of the amount of time. Multiply the 4 times 4 times 4, that cancels, you get 44. It's x, so that's D. And that is it. Let's go ahead and check our work. And that wraps up linear expressions in one, or linear equations in one variable. So we've got AE4, B, B3B, C, 95B is 480. 122 is 1250. B, 180, 24, good. The first 8E8 is B. The second 8E8 is C. We got 01B. I changed my answer on this one. It's D. Good. We got A7F, A, EF8, B. Yep. FF0, B. 129, B. 0B6. What do we got? Where is it? K is 5. Okay. 59, 0A9, C. BBD, C. 652, A. A21, C. AA4, D. 3F1, C. And finally 062 is D. Great. And that does it. That's all of our work for, well, that's half the work anyway. There's a workspace too. It's linear expressions in one variable in the bag from the College Board Question Bank as of April 2024. If you learned anything, if you saw anything where I made a mistake, please let me know in the comments below. If you liked what you saw, please give us a thumbs up and a subscribe, and I will catch you guys next time with linear equations in 2 variables. Thanks for watching.